Hi everyone, so in this video we are going to discuss the models for software reliability by HK Swag. So welcome to my channel. So in this video we are going to discuss about what are the models for software reliability. So let's get started. So first of all we learn about definitions of software reliability. So according to 1991 IEEE standard, the definition of reliability is the probability of failure-free software operation for a specific period of time in specific environment. So the quality of growth improve over time, and we talk about reliability growth. Software reliability growth problem, it is the problem that estimating and predicting the reliability of program as faults are identified and attempts made to fix them. So what is fault density? The number of faults per 1000 line of executable source code. So these are the definitions of software reliability and fault density. Software reliability growth problem, what are the problem, and the quality of products improve over time and time. So using reliability model, suppose that we have developed and tested our software and documented the failures for a certain period of time. So how do we know that the reliability software is getting better after bug fixes? So how to measure the increase and decrease of reliability? So these are the taxonomy of software reliability models. So software reliability models are divided into time independent and time independent. So time between failure and failure count, fault seeding and equivalence classes. So these are the time dependent reliability growth models. So common software reliability growth models are basic exponential model, logarithmic Poisson model. So the basic exponential model assumes finite values we know in infinite times. The logarithmic Poisson model assumes infinite failure times in infinite failures. So these are the parameters involved in reliability growth models. First one is fault intensity, number of nature or unit time. Execution time, time since the program is running. Execution time may be different from calendar time. Mean failure experience, mean failure experience in a time interval. This is represented by mu. So discuss. One problem with model is an overwhelming number of model has been proposed to address the issue of software reliability assessment. So we must be aware that no single model can be recommended universally to users and any circumstances. To use under any circumstances, the best model may vary from time to time and different from application to application. So this is the time dependent reliability model. Fault injection model, this is the time independent. So insert in a software model a certain number of faults and proceed it with its testing. This is second point, and count the number of failures due to injected fault. Is represented by F. The count the number of failures due to inherent fault. This is represented by I. Estimate the number of faults. So this is the formula A by F equals to N by I. So N equals to A by F into I. So this is the example. For example, A equals to 25 faults. Proceed with testing. 32 failures. Count the number of failures. F equal to 17. I equal to 15. So N equals to number of remaining fault A by F into I. So I is the 32 minus 17. Testing minus inherent faults. So this is the I. So if you not artificial fault have less than A, then This will be the formula. 0 if I greater than a by f minus 1 into e plus 1 plus 1 plus a e plus f if I less than equals to e. If all artificial faults have been founded f equals to a, then probability of no more than e faults equals 0 if I less than e, a by a plus e plus 1 if I less than equals to e. Confidence level about the number of faults. Let's set e to 10, f less than e, a equal to 25, I 15, f 17, e 10. This will be the formula no more than 10 faults. Assume all artificial faults have been found f equals to a, given e equals to 10 certain number levels lambda I less than e, lambda less than a by a plus e plus 1, a greater than lambda by 1 minus lambda into e plus 1, lambda equal to 0.9 by 1 minus 0.9 equal to at least approximated value from. So time independent reliability model. So software reliability dependent on how software operates on software domain. According to how software is used. So this is the software user information includes the environment information where software used as well as the information on the actual frequency of the usage of different operation functions or features that the system offers. The usage information is quantified the operation profile. This is very important topic, the operation profiles. So input domain equivalence classes. So this is the input domain, output domain. In center it is software model. The diagram that represented equivalence classes. So operation profile, this is very important topic that will definitely come in exam. This is methodology to develop operation profile, determine customer profile or users context profile, determine user profile, determine system mode and their profile, determine the functional requirement profile, determine operation implementation profile. So what is operation profile? A set of relative frequency or probability of occurrence of disjoint software operation during its operation use. Software-based system may have one or more operation profiles. Open profiles are used to select test cases and direct development and testing and maintenance effort towards the most frequently used or most risky components. So these are some points. Construction of operation proceed by definition. Customer user profile, system mode and function profile. Profiles are constructed by characteristic hierarchical list of structure. For each item, probability of its occurrence as provided by quantitative description. So user profile. A user is a set of users that system in the same way. Actual users are not its SC customers. If the subscriber 90% operator 5%, customer care 5%. System mode, it is a system or mode is a set of function or operation that are grouped together for the convenience of analyzing the execution behavior. So these are common reasons for grouping: function relatedness, environment condition, criticality, user experience. System mode example: normal traffic load, high traffic load, start and restart, administration, troubleshooting. So function profile depend on customer, user and system mode. For example, MO SMS 5%, registration access 25%, call access 70%. Depend on customer, user, system mode and function. This is a diagram. You can see that this is subscriber, MO SMS, user. This is the operation profile diagram. It is a graphical representation of that. So input domain, equivalence class and operation profile. Path E1, each path is associated probability, assume right independent. So P1 equals to 0.35. So these are assumptions. C equivalent EI. At PI the probability right input will be come from EI. Number of test cases from J input IJ. Estimate probability from 1 minus sigma equal to 1 Fj by Nj. So this is system reliability of individual components Ri. One can easily compute the reliability of some architecture as follows. So this is the architecture of that. system reliability. So these are the classes of reliability models and their main features: time between failure, failure count, fault setting, input domain. So let's understand it one by one. Time between failures: independent time between failure, independent random variable, equal probability of exposure to each fault. Fault count: testing interval treated as independent variables. So fault setting: seeding faults randomly distributed. Input profile distribution on random testing. So reliability, this is also very important. For example, if I want to go to Bombay and I want to book a train, so I will see that in which time it is available for going from Delhi to Bombay. So that is the availability of anything. System is available for specific period of time or not. So this is the availability. So this is the formula, you can learn it. Lambda is failure intensity, Tm downtime per failure. So this is the MTTF by MTTF per mean time to failure plus mean time to failure plus mean time to ratio. So guidance for following: applying product and project measures throughout the life cycle, optimizing the development of reliability, maximizing reliability, developing manage reliability in same manner. So these are the more download tools. You can download it somewhere. You can find the reliability engineering. So thanks for watching. This is all about models of software reliability. According to my end, it's over now. So this is part 2. So thanks for watching.